Good morning. I am Dr. Kornaya Billa, Professor, Lakkireddy Balareddy College of Engineering. Today, I would like to discuss small signal low frequency amplifiers. What is amplifier? Amplifier is the electronic circuit which amplifies input weak signal, produces output whose amplitude is larger than the applied input signal. Basic component is required to design amplifier is transistor. Transistor is a nonlinear device. The circuit which is designed with the nonlinear device is called as a nonlinear circuit. The analysis of the nonlinear circuit is very difficult. So to simplify the analysis of the transistors, its operation is restricted to linear characteristics region, that is active region. In active region, the transistor exhibits linear characteristics. This approximation possible only if the applied signal is a small input signal. So to analyze the amplifier, the transistor is replaced by its equivalent linear approximation model, that is H parameter model. The small signal low frequency amplifiers are analyzed by using H parameter model. H parameter model. Amplifier analysis. Amplifiers are analyzed by two ways: DC analysis and AC analysis. So DC analysis for biasing, AC analysis is used for measure gain and input and output impedances. Analysis of CE amplifier. The CE amplifier is designed by using CE configured transistor. In CE configured transistors, the emitter is common to input and output. CE amplifier is used to amplify input weak signal and produces output whose amplitude is larger than the input signal. The CE amplifier circuit is shown in figure. Here C1, C2, C3 are the three capacitors. C1, C2 capacitor is called as a coupling capacitor. C3 capacitor is called as a bypass capacitor. C1, C2 capacitors are used to coupling the input and output to the transistors. RB1, RB2, they are the biasing resistors which are used to set the operating point properly on the center of the load line. To analyzing the CE amplifier circuit, we have followed some steps. Step 1, all the capacitors are short circuit. And second one is DC power connected to ground. Third one is redraw the modified circuit. Fourth one is transistor is replaced by the its equivalent model. So see that one here. That means all the capacitors are circuited, the modified circuit again here. So that means power supplies are grounded, then it is a modified circuit. And fourth step is the transistor is replaced by its linear equivalent model, that is the H parameter model. Then the equivalent circuit of the CE amplifier using H parameter model as shown in figure. That means it is the voltage between the base to emitter is called as VBE, and output current of the IC is the load current I. You see that one, IC and IL both are passing the same branch, but which are passing in the opposite direction. Then IL equal to minus IC. IL equal to minus. So from the figure, so the voltage between the base to emitter VBE equal IB into HIE plus HRE into VC. That is the equation 1. Output current IC equal, that means it is the sum of these two branch current, that is the HFE IB plus 1 HOE into VC. It is the equation. We have to modify this. So to measure the current gain, the current gain is defined as It is the ratio of output current to the input current. So A equal IL by IB. We know that one IL equal minus IC, that is minus IC by I. So from the figure, so IC equal HFE IB plus HOE VC. We see that one. What is IC here? So IC is nothing but this current plus this current. That means this current is HFE IB. The current which is passing this one is HOE into VC. So that's why this is the modified equation. We know that one output voltage VC is nothing but IL into RL, that is nothing but IC into RL. It is substituted into above equation, that the modified equation is IC equal HFE IB minus HOE IC into RL. You have to again it is modified, we are getting this one. Finally, we are getting A equal minus IC by IB. So from that one HFE 1 plus HOE into RL. It is the modified final equation for current gain. Final equation for current gain. Similarly, second one is input impedance. What is the definition of the input impedance? Input impedance is defined as it is the ratio of input voltage to input current. Ri equal VBE by IB. So from the figure, what is the VBE equal? The VBE equal from the figure, VBE is the voltage across this resistor plus this voltage. That is nothing but HIE IB plus HRE VC, which is here. VB equal HIE IB plus HRE VC. We know that one. What is the VC equal to ICR? We have to substitute at here. So from the what is the RI equals? So VBE by IB. It is the VBE. This is the equation. The IB. The above equation is divided by IBE. Then HIE divided by IB. IB get one. HIE plus HRE IC by IB into RL. We know that one IC by IB is nothing but A. That is substituted here. This one. Modified equation is Ri equals HIE plus HRE A into RL. But AI equals HFE by 1 plus, we are getting this one, HFE 1 plus HO into RL. We have to substitute we are modified this equation is input impedance Ri equal HIE minus HFE HRE divided by HOE into Y. Similarly, last one is voltage gain. Voltage gain is defined as it is the ratio of output voltage by input voltage. That is nothing but VC by VB. VC is equal to minus ICRL divided by IB into R. So IC by RI is IC by IB equal to A. It is AI into RL by L. So it is a voltage gain. So to analysis means we have to find out voltage gain, current gain, and input. Thank you, one and all.